Hello everyone, I'm Sandhya. Today I'm going to present an influential and foundational paper titled A Relational Model of Data for Large Shared Data Banks by E.F. Core. This groundbreaking work laid the theoretical foundation for modern relational database and systems. I'm excited to share its key ideas and significance with you. The paper titled A Relational Model of Data for Large Shared Databanks by E.F. Ford, published in 1970, revolutionized the way data is organized and accessed in database. It proposed a new, more efficient and flexible model for storing and manipulating large volumes of data. The relational model introduced in this paper forms the theoretical foundation of modern relational database management systems like MySQL, PostgreSQL, and Oracle. I chose this paper because of its historical and practical significance. It lays the foundation of almost every modern database systems we use today. Understanding this paper not only gives me a deeper insight into how relational databases work, but also helps in understanding key concepts like data independence, normalization, and query languages that are crucial in both academic and professional contexts. As someone working on a DBMS project, studying this paper helps me appreciate the theoretical backbone that supports relational database systems used in real life application. Major topics discussed in this paper are there are many topics discussed in this paper. First one is motivation for a new model. Ford identified limitations in existing hierarchical and network data models such as complex navigation through pointers, data dependency problems, lack of independence between data structure and application programs. He argued for a new approach that separates the logical view of data from the physical storage, improving flexibility and the stability. And the second one is the relational model. Data is represented in relations. A relation is a set of tuples having the same attributes. Each attribute has a domain. Primary key ensures uniqueness of tuples. Third one is data independence, logical data independence. Changes in logical structure should not affect application programs. Physical data independence. Changes in physical storage should not affect logical structure or application programs. This is one of the key advantages of the relational model over hierarchical or network models. Fourth one is integrity rules. Ford proposed two basic types of integrity constraints: entity integrity and referential integrity. Entity integrity, each tuple must have a unique identifier, and referential integrity, foreign keys must match primary keys in related relations or be null. Fifth one is relational algebra. Code introduced a set of operations for manipulating relations, which later formed the foundation of SQL. Select. Select extract rows that satisfy a condition, and project extract specified columns. Join combines rows from two relations based on a related attribute. Union difference intersection Cartesian product. These operations enable powerful and flexible query capabilities. And the sixth one is normalization and redundancy. Although normalization theory was developed later, Ford introduced the idea of eliminating redundancy and anomalies through decomposition into smaller relations, which became the foundation of normal forms. The seventh one is advantages over other models. Ford emphasized several key advantages: simplicity in data representation, mathematical foundation ensures correctness and optimization, greater data independence, improved consistency and integrity. Implementation considerations. This is the last one. Although the relational model was theoretical at the time, Ford discussed practical implementation challenges, query optimization, storage structures for efficient access, indexing techniques. These would later be addressed by commercial RDBMS software. And with this, we can conclude that EF code relational model marked a paradigm shift in the field of data management. The principles introduced in the paper have stood the test of time and are still in use today. By abstracting data into simple, well-structured relations and supporting powerful operations for data manipulation, the relational model provided a foundation that is both theoretically elegant and practically effective. Studying this paper not only deepens understanding of database theory but also enhances one's ability to design efficient and scalable data systems, something crucial in both academic projects and industry level applications. Thank you.